I actually, what I did was I took the opportunity while the stream was down for a few seconds there. I took the opportunity to just reset my camera in the new position. I need to refocus it still, but the brunt of the work is done. Yeah, oh god, this Ethernet cable is so delicate. I move my laptop, it falls out. That's happened a couple of times now. We're back, and you didn't miss anything because you heard me saying like, oh, I'm just gonna move my laptop. Crunch, it stops, and the stream came back within 2 minutes, and so I'm not. I think, yeah, I think we're still live, and there's no problem. I'm not. I'm not too bothered about that. We didn't lose anything, I don't think. It's like, a Raft server disconnecting. Ooh, persisting state. Well, whatever was saved was saved. And everything that is useful was saved, I'm pretty sure. Well, we'll see how it goes. But yeah, I mean, at most I could have, because of the latency, at most I could have lost 15 seconds. And I didn't say anything in those 15 seconds other than I'm going to move my laptop, right? So, whatever. Fuck it. Pretend it didn't happen. Okay, I'm still live. Camera is working. Mic is working. I'm Mike D, and I'm back from the dead, chilling on the beach down from Club Med. I'll say, okay, so yeah, I mean, it was just that discussion about whether to persist current term. I don't know. Because, like, if term has gone back in time as a result of everyone crashing, then there will be newer terms in the log. Oh yeah, this is what I was going to say when I said hold that thought. Basically, so the last thought that I had. Basically, in the case of append entries, the leader dominates, and everyone should have a copy of the leader's log by the end once the leader's done synchronizing everyone. And so, the leader stops being a leader if at any point somebody else's term is bigger than its term, which means the leader's term is maximal, and all the followers, they don't care about the terms in their log, even if the terms are bigger, they just increase them. Now, vote request is more interesting because vote request, a voter only votes for a candidate if its log is up to date, and the log up to datedness relation specifies that the last entry has to have a bigger term. And so if a candidate's last entry has a term that exceeds its own term, or the voter's term, or anyone's term, then the votes are going to come back false. But there will be re-elections eventually, and because of term sync, everyone is more or less synced up on election term, and so it's not like they increment their own terms one by one. Instead, someone increments term by one, there's a failed election, and then because of RPC term sync, the term change propagates, and then someone else increments, and that happens until we catch up. So that shouldn't take too long, but I think that is working as intended. Certainly, according to this blueprint, that is how we pick up on data. That is, yeah, I mean that's how we manage to pick up on data that is in the log with a term that is newer than everyone else's term, which can happen if everyone crashes out and hasn't saved their term as recently as it could possibly be. That's the point. So candidates only ever increase their term if they call an election. Nothing. Oh, and if there is a term sync between them, that means that we'd have to start from scratch if we didn't persist current term. Electing, running n elections until we get up to n term, which is the latest term that happens to be in somebody's log, because logs never get edited unless there is a leader saying you need to edit your log to a follower. And there is no leader as a result of that until somebody's term exceeds the last possible term in the log, I think. Oh no, that's not how it works at all. I said a bunch of crap. Sorry. Log up to datedness is not about what the latest term in the log is. It's about comparing the log of the voter and the candidate and saying who has the later log. And so the one with the newest log wins. On the other hand, it is possible for things to be committed, as in it's possible for things to appear in the log whose term has gone down as a result of that. Yeah, that's dodgy, isn't it? Is that supposed to be allowed to happen? If the election term has been reverted, then the number just can go down in the log because the log doesn't get deleted. That is so strange. I don't know. I don't really understand. It's possible for me to just stop questioning this. The whole point of this entire chat that I've gone on here is that I am basically, I don't know. I'm trying to figure out why certain things are persisted. And what happens in that situation where everyone crashes and then restarts on like zero term, because terms think, then that means that everyone is on zero term and has to build up term again. So whoever has the latest log entry, but the term is only ever increased by one every time there's a new election. But looking at how voting is done, what we do in order to grant a vote is we compare terms in the log, and the terms in the log are, in that case where everyone has restarted, are going to be a lot higher than the terms of the actual servers. So they'll still grant votes and stuff. And then there'll be a leader, and it'll take requests, and it'll print stuff in the log that has a lower term than the stuff that was previously in the log. Surely. I mean, I'm going to follow the instructions, and the instructions say, this is what you're persisting. Cool. I'm happy to comply with that. But I'm just saying, surely this is now a possibility. It's possible now, if everyone crashes, for term to actually go backwards in the logs. Isn't that a bit sus? In it just, I don't know. I couldn't tell you, man. I couldn't tell you what's going on here. So I'm just going to implement it, and maybe I'll find out a bit more in testing. But for the time being, that's enough chat. I've kind of just pulled up this case while trying to get the intuition, the motivation for why current term is persisted. Log, I have said that's persisted because we don't want to restart the log if it's massive. Voted for is persisted if and only if current term is persisted. And then these things, it's fine if they are volatile, because why wouldn't they just get updated? The leader syncs everyone up once there is a leader, and commit index comes through, and yeah. Basically, it gets updated fast enough by the normal data cycle that there's no point persisting it, I guess. I don't know. Maybe there are arguments against persisting it, but I'm happy enough that it doesn't need to be persisted, and so it's fine. Literally all that we are persisting is current term, voted for, and log. So current term, voted for is always edited in tandem with current term, except when voted for is set during an election, okay. And log as well. Updated, it says here that persistent state is updated on stable storage before responding to RPCs. So the unstable storage is, okay, a detail that you remember is said that we're not using the hard drive, but it doesn't matter what we're doing. We don't care how it's updated, we just care that it is updated. So updated before responding to RPCs, that's a big hint. So it's telling me here I should update before responding to RPCs. So I can't be bothered to even question that hint. So let's just read through all this stuff and try to use that as a kind of bias, I guess, because I don't care why it's true. A bias to figure out where calls to persist should be done. These calls to persist are like, do we have any other hints about this, by the way? Somewhere it told me about comments in the code that talk about persistence. Sorry, I'm just reading through this to check if the optimization I did is along these lines. Oh, there's actually... This is a bit weird. I forgot to check this out. When I was dealing with the optimization that I did in the earlier section of this stream, I forgot to check out this. Okay, I'm putting this in my to-do list and I'm going to come back to it. I'm just throwing it straight in my to-do list. Start command, check the index, return. That's something I've done because I literally had to fix that. I'm glad I put it in my to-do list because I literally predicted that I'd done it wrong correctly. Lol. Check if logs should have type log entry or pointers to log entries. Because it's just a list of log entries. I mean, this is kind of meh. I'm gonna double slash it to represent that I think it's not important. But yeah, notes. I'm not even going to paste the thing that I just copied. I'm just going to say notes in Raft paper about next index optimization. Yeah, the Dell XPS 13's keyboard is lousy, by the way. Notes in Raft paper about next index optimization. Check notes. Alright, fine, let's not all dwell on that. I'm going to keep going. Where does it talk about comments? Raft.go contains examples of how to save and restore persistent state. Okay, let's have a look at Raft.go. What is here? Well, we have read persist, which is of course initialize from states persisted before a crash. This is the function that is oh right, okay, yeah. This is a call to read persist. At the very beginning of the make, the make function is the initialization function. It initializes state. This is a load state, and so it runs read persist, and it runs that using the persister object calling one of its methods because notation's a bit arbitrary. I don't know. Doesn't matter too much. But yeah, if we find the stuff about persistence, yeah, we have here, read persist the data. If data is nil or the length of the data is less than 1, meaning equals 0. Why does it say less than 1? Length of data is always an unsigned integer, and the non-signed integer being strictly less than 1 means it equals 0. Notation is just cleaner this way. And then it just returns. If there is no state, then just don't do anything. Yeah, that's completely fine, like load defaults. Then there is some implementation stuff. I said I was going to YOLO it. I'm just going to, try to read this and do it. This is the actual persist function that is going to do the persistence. Yeah, see figure 2 for a description of what should be persistent. We know it is the current term and the associated voted for variables as well as the log. And there's nothing else here that we care about. So we just need to call the persist function, which has no arguments. Okay. Yeah, because we don't need to pass. We've already, upon initializing the Raft instance on the server, we've already passed it a reference to the persister. It's only in load persist. Sorry, the loading, the read persist that we need a reference to the persister. As in, well, no, this is where the persister is mentioned, and then the program keeps a note of the reference, I guess. And then when we run persist, it just automatically saves to that reference. I don't know, I'm just trying to figure out why read persist has an input in it instead of just referring to that persister object or whatever. And save persist has no arguments for whatever reason. Who knows? maybe I need to put arguments in. And there's nothing else here that is relevant to what I'm doing. Everything else was just done before, read through before. Okay, some information about snapshots and that stuff, which we're also not implementing yet. Snapshots are a way of saving data so that we don't have to keep dealing with it. Yeah, sending apply messages is also just not relevant to persistence. Yeah, nothing else. Okay. The API, which I always call the interface. Well, I guess the letter I doesn't literally means interface, so it's cool. It's cool that I just refer to it as that. Totally okay. Base, mic, live 119. Okay. Yep. Well, all we are doing is calling rf.persist in random places in the code. So it says here in the blueprint, it literally says before responding to RPCs. What I'm going to do as my first step into looking into where things should be done is look at where the term and voted for and logs variables are updated. So we're looking for writes to those variables. So I'm going to control shift F of them. So first of all, rf.currentTerm. Where all does this apply? Well, you can see here, rf term gets incremented. This is just reading from current term. This is also reading. This is reading. This is setting. So common, we set. Here we set as well. Here we just do a lot of reading. Here we read. RF current term gets read by all the print debug statements. It gets set here. This is a comparison, so it's also a read. So the only places where we increment current term are when the candidate starts a vote and upon term sync. Those are the only positions where current term is changed, and voted for as well. Okay, so where else? Voted for, whenever current term is changed, voted for must get set to -1. So we can just quickly verify that that's what's happened. Yeah, in both of the places where current term increases, it always increases. Voted for is set to -1. Where else is voted for set? In a few different places, actually. This is initialization. Voted for gets initialized to -1 by default, because this is the default value of voted for. 0 references a server that exists, like in the peers list, and so we can't use 0 as the default value. So this is totally fine as well. Read persist will set that to something else if necessary. Where else are there voted fors? Well, the two that are reset when current term is increased, okay, those are fine. But we also have a few others that are edited. So this is a read, this is a read, this is the reset. This is the reset, and so here we have voted for set, here we have 2 reads, and here we have another voted for set. So request vote, sets voted for. Candidate also sets voted for. Okay, candidate sets voted for only in the situation where it votes for itself. Okay, fine. Else voted for is set based on, the request, the thing that receives request vote sets its own voted for here. So these are a couple of positions where, so we know we have a mental note. Let's just put it down in Notepad so that I don't forget. A mental note of where these things are edited, right? So current edits One of them is new election candidate. The other one is RPC term sync. Right, voted for gets edited. The above. But also, when else does it get edited? Voted for. What did we just say? It gets edited. Candidates voting for self and voter, so request vote RPC handler, voting for someone. Do I even want to save this? Let's not save it for now. Just stopped by, can't stay long. I just wanted to say hi. Standing in the window. Actually, I don't remember how that song goes. Hi. You know, Jay Dilla. Maybe not. Doesn't matter. Hi. Nice to have you on board. No worries about not being able to stay for too long. I'm just... At the moment, I am looking at persistence, which is about saving state and resuming state in case Raft, the server, crashes. Much like an emulator. It's a very much identical analogy. So I'm looking for the places, I know which variables I'm supposed to save when I save state, because it says it here in the blueprint, just these three. And so what I'm doing is looking in the code, wherever those are edited, I'm just making a mental note for where might be a good time to save state. Pretty simple what I'm doing, to be honest. I keep saving, but I'm not going to save. I'm going to be done with this today, I swear down. Alright, so I've looked at where current term is changed. This is that. Voted for is always reset when current term is edited, but as well as that we have these two situations where voted for is edited. And the last thing is log. Log is going to be all over the place. The log gets edited just everywhere. Not all of these. So what I'm doing is searching through my entire project for references to this to find where it's edited. Pretty simple. But not all of them are edits. Most of them are not edits. So for example, we're really looking for rf.log to be on the left-hand side, right? So here we're just getting its length. Here we're just copying over its. Here we're just accessing it as well. So the candidate never edits the log. Common, just it checks the last thing in the it reads the log to find the command to send. This is a print debug statement, so that's all about reading as well. Here we read the length of the log, and why is this here? Yeah, as in, this is something I wrote yesterday because I don't understand why this is here instead of further down in the code where it's more reasonable. But I have to have it here or the code crashes and I can't be bothered to debug it properly. So I just left it there as a kind of sticky tape solution. I'll debug it later. I'll probably fix that eventually. Reading the length again. Here I'm just accessing the log, reading the length, accessing the log, reading the length, accessing the log again, print a debug statement, accesses something, doesn't matter what, this one. Scroll to the left, the P means print to debug. Leader does not edit log. What is all this stuff? We have a few more edits here. So request vote also just reads the log, accesses its length and its term, so none of that. So we have a few clear edits of the log happening here. Okay, so let's have a look. So again, this is length, print, debug. So we have these four statements. For starters, Raft.go handles the interface of Raft. And so in four different places where we are ostensibly appending stuff to the log. One of them is in start. Oh, this is the same thing as this one because our append is always written in this syntax. So one of the places where the log is edited is upon start. So I'm just going to describe that as log edits, one of the places where the log is edited is leader receiving data, which happens in the start function. Any new data just gets straight appended to the log. And this, which is the make function, and what that does is it appends the empty dummy entry to the log. And so the entire point of that is that it initializes the log with a dummy entry in the 0 position, thereby making it as if it's 1 indexed. Because we want the first instance to be 1 according to the specification, the first entry in the log. There's no 0th entry. So yeah, this is server initialization. Always edits the log, creates the log. Because this is just, it's not the default value. So the same goes for voted for. Oh, but this is, I don't care about this because it's in the make function. And so it happens before state is even loaded. So therefore I don't actually care about this one. I'm not writing those down because I don't need to care about them. Because I don't persist before I load. I don't save state before I load state. And I only ever load state upon starting the server. I save after that. Seems good. So that covers all of those, I think. Yep, this is receiving data and this is starting up. And print debug length. What else do we have? Here we're reading the length. Here we are accessing the length to check something. Length again. This is again accessing. And so this is the last statement. And so merge log, follower merging log. Okay. Merging what the Control S again. What the leader sends. It's good that you have, it's always good in life to have the compulsion to keep saving. It's less necessary than it used to be, but back in Windows 95, even XP days, pull the plug on the computer and rip. Nowadays, things automatically save state much more often because we are in more enlightened times. You dig. Live, camera's still working, mic. Yep, so the 2 hints that we have now, we have these 6 positions in which these variables are edited. And we also have the hint that it said in the blueprint, save state after responding to RPCs. Not even after, sorry. Before responding to RPCs, we should save state. Cool. So does that check out with this? Do all of these things, conceptually speaking, happen before state is saved? Sorry, before responding to an RPC. Follower merging log is, yes, this happens before append entries is responded to. The follower merging log. Leader receiving data, that happens just whenever start is called. So that has nothing to do with an RPC. That doesn't conform to that. Whereas, yeah, okay, let me make a note again. It's not even before replying to the RPC, it's just during the reply. Most of the replying is actually done here, but then it says if success, then we do a merge, so it's just somewhere during the RPC handler. How does the RPC work again? So it spins up a thread. Server A, the initial one, sends it to server B, and then it hangs waiting for the response. But how does it know it received the response? I think it knows because the response handler returned. I mean, it does set the response variables during that function. But how does it know that it responded? That's a bit of a subtlety I don't think I've thought about so far. So here you can see the responder is just doing stuff. It sets a lot of the replies, but is it, how does server A know that server B is done doing that? I think the only logical way, the only reasonable guess I have for how that works is that the receiver's handler of the RPC has to exit. somehow, because else it would have to just time out using absolute time, and I'm not sure that's what should be happening. Maybe, I mean, usually with message pass sending like this, sending and receiving, it's like, okay, if there's a timeout, we have a timeout that says, okay, it times out if this much time passes. But before then, we just allow it to respond and say it's responded. So obviously, it is possible for, because of the way that responses are structured, responses are saved to the replies variable. Oh, but yeah, the responses are saved to the replies variable on the on server B, but server A doesn't have access to that until it actually receives it. And when does it get sent it? I think the answer has to be at the end of the handler. There's no other reasonable guess. And so, it sends back. If the handler, if we can, what I'm saying, as a result of that, of what I just said, what I'm saying is that means that we can persist state anywhere in the handler, because the response is only sent after the handler exits. That's my theory. And so I'm saying, okay, my hypothesis, I should say. This isn't Pokemon Go or like normies using words like theory just for wild speculation. This is science. We have higher standards. I probably shouldn't use the word normies like that. It's a bit condescending. But yeah, that's what I mean. So, these variables can get sent anywhere. They can get set anywhere in the handler of the RPC, which is cool. And assuming stable behavior, we should be able to set them anywhere in the RPC, because it then returns it doesn't actually return the reply at all. It returns nothing. But just the sheer fact that it exited, I think, triggers the fact that this function returns triggers the fact that what has been saved to replies, a reference to that then gets sent back over the RPC to the sender, to server A. And that has to happen at the end, or else, if it happened in the middle of this, then we wouldn't know where we could set the reply. So that's why my theory came to be the way it came to be. And that means we can persist state anywhere, and it'll be before the response. So yeah, during append entries handler, because during an RPC handler means before the RPC replies is sent. So that conforms to the specification. Voter voting for someone is the same thing. That's always done during vote, request vote, handler. Candidate voting for self is unfortunately not done during that, but if I am the candidate, I'm probably not going to be receiving these random vote request vote RPCs, and so I guess I may as well persist the fact that I've voted for myself. What happens if I don't do that? I think it might be a case of no harm done. To make the code, optimized, I don't want to do any unnecessary persistences of state, and so if I can skip some, that would be. Okay, so new election on the side of the candidates, that increases current term. And RPC term sync does as well. RPC term sync means that it's not just during the handler that RPC term sync can happen, but during, after the send is complete, RPC term sync will have happened on the sender's side. And so we should persist then as well. The thing about, we shouldn't do the persistence during the RPC term sync method, because then we would be persisting twice on the receiver end, because you can see here, term sync happens immediately. So if we persisted here, we wouldn't have a clue what the replies are. And indeed, it's somewhere in here that RF log is getting edited, for example. And so we shouldn't persist here, because then we'd be redundantly persisting here and down here after this edit is done. So that means we shouldn't persist during the term sync function. And the sender should therefore also have persistences of its own. So RPC term sync, RPC handlers not term sync. I don't want to do this persistence during the term sync routine. Candidate starting a new election. That's okay. So we have these three different cases of when we might persist. Okay, I'm definitely going to persist after every RPC because I was told to by the blueprint. And that means that I am persisting after this case, and this case, and this case, as per what I've just said. On the other hand, we have these three cases that don't conform to that pattern. And so my question is now, do we care? Do we need to persist at all after these three things? So let's go through them. Number one, leader receiving data. That means that the leader has some extra stuff in its log. Do we want to persist that at all? I think the answer is no, because only the leader has stuff in its log in the event that, imagine the leader just received some new information and it hasn't had the chance to send it out to anyone else. The thing is, once the leader sends that information out to everyone else, then per the RPCs, save state will be saved at some point after the RPCs. Handler after the... Well, in the case of the leader, it's after the sender, and after the leader does term sync, which is after it's received the response from server B, so the leader being server A, so that A and B can sync terms, and that has to happen at the very end of the RPC exchange. And so that means that if this doesn't get synced, if this doesn't get persisted, if there is no persistence after this, that means that the data was not even finalized as being sent out to anyone else. And it's slightly sketchy, actually, because first the data is sent to the followers. The first the leader commits it, and then it sends data to followers. The followers persist for themselves. But then, it smells of shit outside, as usual. Thanks, London. Because if that data gets saved by the followers, but then the leaders only save the data after their term sync is done, which happens after the follower has responded, which means that it's possible for the leader to lose the data if it crashes, but the follower to have saved it. And so then the data is only with the follower, which is a bit strange. I don't know, man. I don't know. Does that mean that I should be persisting state after receiving the data? It is a bit of an edge case. It means the follower has data, the leader doesn't. It means the follower is more likely to get elected in the future, but do we really need the leader to save state there? Because the state will be saved when more people have that entry in their logs. And if we lose the leader, that's unfortunate, but unlikely. As in, if we lose the leader's copy of the new data and the follower still has it, that's an edge case. More likely, it's much more likely to happen. Yeah, because if we persist at the very end of the follower RPC handler, then the RPC gets sent back, and then the leader immediately does term sync and persists right after that, and that's such a small window of time that it's unlikely the leader will crash in that time. And that's the only case where it might be better, and I emphasize might be better, to have persisted the data with the leader. For the most part, no. If only the leader has data, then the client may as well just send the data in again. Sorry, the leader crashed. There's a new leader now. So yeah, let's not persist. Let's not persist in this situation. Alright, that's a lot of time spent talking about that. Okay, this, candidate voting for self. Oh, this is so stupid. It's like, I have to set voted for to nobody, so that I don't... As in, I have to, if I am the candidate, I have to set myself as voting for myself because if I don't do that, I could end up voting for both myself and someone else. And that applies to if I'm the candidate and I crash and then I become candidate on the same term or something, or voter even, I may have sent votes to more than one server. So every time the candidate votes, it should 100%. Sorry, this is the thing. So voters vote, but the candidate never votes for itself via RPC. On the other hand, the candidate, we're saying the candidate should probably persist. It should probably save state after it's voted for itself, for this reason that I just said about making sure that even if it crashes, it doesn't vote for two people in the same term. But we also have a new election by the candidates. My thoughts here, my thinking is that new election should not trigger a persistence, but this should trigger a persist. And the reason for that is simply that, a candidate starts an election. If it crashes, then if we have not persisted after the new election, all that means is that we've not updated the candidate's term. And so when the candidate comes back, its term will be +1. It will be incremented literally by 1. That's the worst case. Because every candidate cycle, it only ever steps up by 1. The current term of the server that is in the candidate phase. And so we may as well not persist until after the candidate's voted for itself. So then we capture both the self-vote and the new election. Because before then, there's a new election, so term has gone up, but there has been no vote by the candidate itself. So, I mean, what's the worst that can happen then? The candidate should just forget that it even triggered an election, because it may as well be living in the past, because then it will get term synced into the present, and then again it's as if it's just voted for nobody, right? It's the same outcome. So yeah, I would say forget that we've done this, but if I have already sent out vote requests and voted for myself, then it's probably for the best to persist then. So I'm basically just saying persist during the handlers of the senders and the receivers of RPCs, plus an extra sneaky persist in the candidate code, voting for myself. Okay? I'm going to save this regardless. I've decided it's useful enough for me to save it. The place where I'm going to save this is... how much free space do I have? Most of the hard drive. I do need to clear out all those test videos for my stream. I still test my I always still test the synchronization of my audio and webcam video. So my mic audio and webcam video. I always synchronize them before every term, but I haven't before every stream. But I have not actually had to change anything for, I think, over 10 streams now. So I don't want to stop doing it. It's good practice. But like when I was using the Android as my webcam, the Android phone, I had to resync it explicitly every time. It would always go out of sync. But now it's dedicated hardware. It's always in sync, because Android is an extremely unstable operating system. Particularly working on a bad phone, it's a really bad operating system. But I mean, PC operating systems are much better, but you'd be able to, I think, expect more stability from iOS, I think, but I don't know. So this is all when to persist. Call it the 2C code, 2C when to persist. Just some notes that I made for myself. And I mean, sure as I've done this, I'm literally just going to throw down the implementation. As in, I'm going to literally just type rf.persist in all of those places. What's the worst that could happen? Literally just performance slowdown. I think saving state is just one of those things that might take a few moments. So you don't want to be doing it like compulsively. On the other hand, because I have really whittled it down and have a fairly optimized, this is where I want to save states, I'm pretty safe to just put those in, I think. Nothing can much go wrong. No need to test yet, because I haven't implemented anything else to do with persistence, so I'm just going to leave it. So this is the stuff I've edited. What have I edited in Raft.go? Just that trivial style change. Put something in the to-do list and then made this new file. Okay, cool. I'll tell you what, I'm ready to, I'm just going to implement that then. And then commit, and I think that's it for me with the stream today. I'll get onto that when I'm done with this, but I'm a bit tired. I don't want to do any more work. A bit hungry, I guess. So this is these are the positions where persistence is being implemented. All of them are in RPCs except for the candidate voting for self thing, which is in the candidate code. So candidate code is going to have a call to persistence. Only in the situation where the candidate votes for itself. Because if not, it's completely legitimate, I think, to forget that the election even happened. Because then, if the only way that this block of code does not pass, that this does not happen and is not triggered, is if my voted for is for someone else, but in that situation, in that term, I voted for someone else, so I really should be forgetting that I was ever candidate. And the fact that I voted for someone else will have been saved in one of the RPC exchanges. So I think it's pretty reasonable to just run a persist here. Sorry, what did I just do? Deleted me. And this goes in all of the RPC handlers as well. So the exact positions I want to put this in is, okay, let's go through them. So append entries. First, append entries is sent. Then the receiver runs this, and it does a term sync, and then it does everything else. And so just, at the point, we persist just like, where is a good place to persist state? I would say outside the lock, sorry, so that, something else can be doing, like a server persisting its state, that should be done within the log. Sorry, I'm stupid. Obviously, if you're saving state, then you want to have access to the state variables and no race conditions. Definitely do that within the log. So this is saying if reply.success is true, but we want to persist state regardless of whether success is true, simply because of term sync, and so here seems legit. And then the sender, where does the sender persist state? Answer, after the reply has been received, after term sync has been done. So term sync happens. Yep, the print debug just before that would say persist state. Is this happening in the lock? I think it might not be, because term sync explicitly has a lock. Oh, that's unfortunate, isn't it? Because there is no lock in the sender at all. It's just in the term sync function. So I can't reasonably, because my lock is in a different function, I can't take the lock again. That would take a performance hit. What I'm going to do is hack it slightly. Okay, what I'm going to do, so bear in mind we haven't sorted out the append entries sender yet when it comes to persisting. Instead, I'm going to jump on the request vote receiver. I'm going to put in the persistent state in the same place I put it in last time. So here it says, if react, lock and unlock. If no react, no persist. But again, term sync means that I should be persisting. It's just difficult because the way that I have structured term sync, the problem is that I need to make this decision of whether or not I want every RPC to lock. I lock here anyway because of term sync, but then I lock again if react happens. I don't want to be too anal about how many times I lock and unlock. There is a double lock here, but I'm doing that in order to have term sync as a separate function. But term sync, it locks, does stuff, and then unlocks at the end. It runs a phase change that is asynchronous, but phase change also picks up the lock, and so you can't. It can be a bit difficult, to be honest, because of the way I've split my code up. There is unnecessary locking and unlocking, and it's difficult to get away from that, unfortunately. So I'm just trying to figure this out then, because my function previously, it just locks and unlocks in the case of React. But if I'm looking at, that's the append entries handler. Well, no, the append entries handler. Okay, not gonna lie. This is a bit annoying. What I'm gonna do. What I'm gonna do is double persistences. I do not want any more locks, and therefore I'm gonna leave the option that I possibly persist twice in one RPC. Sorry if that makes it too slow. That's an unfortunate. Oh god, if that starts failing test, then I'm gonna have to, like speed test, then I'm gonna have to rethink this. Unfortunately, restructure the code so that it minimizes locks and minimizes persistences, because those are intensive. I might even have to get a piece of paper out and see if I can structure a kind of flowchart of RPCs sequences in such a way that I can figure out exactly exactly how to minimize the number of persistences, saves of state. That's what I mean by persistences, and the number of locks and unlocks. For the time being, I'm just going to do it in an elegant and understandable way, whereby I put in the persistence after edits, and also the term sync function is going to receive persistence as well. So here where it says, we run term sync, mostly nothing happens, but only if my term is edited, is it reasonable for me to persist. And then I unlock, and then I do a phase change to follow. So the senders of the RPCs don't do anything else other than end on term sync, and so I don't need to put in an extra persistence in those for either append entries or request votes. I don't need to put in an extra persistence in either. It's just the receivers where it is possible for persistence to happen. Oh, hang on. I've just had an interesting thought. You notice the only situation in which persistence happens is if my term is less than the other term. So if the outcome of term sync is -1, this is, here it is, sorry, I zoned out because I couldn't see it. Return -1. So only if the outcome is -1 does a persistence even happen. But React is sometimes true if the outcome is -1. Okay, understood. Because term sync persists in the case of -1, and it also triggers the thing to become a follower, but it also continues to run the React code, and that will require a redundant persistence. Unfortunately, that is going to happen with my current system, but it's fine. I'm not that bothered. If no React, then no need to repersist, obviously. So it's just here where it says vote granted. In that case, I run a persistence. That's the request vote handler. The append entries handler, persist only needs to happen, well, after the log merge is done. But I mean, it's really a matter of choice where you do that. Oh, it should be only if reply equals success now, because if reply is failed, this doesn't run, and so persistence only needs to happen within term sync, which it now does. So just if reply is success, shall we just persist immediately after the log edit, or once commit index has been? I think because this is concurrent and this updates the server's volatile state, I think that should be given priority over persisting the persistent state. So let's put in persist down there, and yeah, pretty much the receivers persist if they edit something. Everyone persists if term sync edits anything. So not every term sync persists, only the term syncs of strictly I am out of date and have to change my term. Only in that case do I bother persisting. So that happens here after those edits, and that's it. Those are the three places it happens, as well as the candidate code. So those are my calls to persist, and hopefully that's not too slow. And that's all that I can say for the time being. Cool. I'm done for today. Nice. So I'm just going to do a quick Control-Shift-F of rf.persist, just to show you guys where it comes up. Again, so let me just close all this stuff down, so I can just flick through it and give a summary. Candidate persists after voting for itself. RPC term sync, if my term is updated, I persist. Append entries, I persist if I've merged my log and edited it, but only after I've set my commit indices. So this is something that only a follower does. Responds to append entries, yeah. Term sync, anyone could be doing that. Candidate is just candidate. And request vote, it's probably a follower that's doing this as well. It just persists after it grants the vote. So there's a nice pattern. After receiver's edit state, every term sync that changes states and just the candidate voting for itself, which is the kind of sporadic case. And yeah, that handles this. So I've said here not term sync, I've changed my mind. Just every term sync. And it's already optimized. We only persist state really if something changes, and that happens always. So it's already fairly optimized, I would say, the code. There's really nothing. Even in some cases when something changes, we don't persist state because we decided it wasn't important enough. We might have to change our minds, but thankfully we have these X's marking those bits that we skipped. So the X's mark the things where state changes but is not persisted deliberately for some reason. Some design decision, some conceit I got in my head or some shit, I don't know. But it's there in this text document, just so I know if something's going wrong, I have this as a possible solution, like just implement it there. Cool. That's it for today. This is session 24 of project 2. Commit. I close down my console. Git push. Yeah, nothing much more to say. I'm going to maintain my 9 PM schedule. It's kind of working out for me fine for the time being, I think. I want to start playing Undertale, and I want to do that after I'm done streaming. So I have work followed by play. That would be sick. I just need to wash my laptop screen, and then I'll be able to do that. So, okay, looking forward to that. And that motivates me to maintain this evening session thing. I do like daylight, but evening session is also cool. 9 PM to 11 PM, you know the ones. Cool. I'm back tomorrow, 9 PM. Easy peasy. During the daytime I get busy on, not Saturday, but Sunday I'll be busy during the daytime, and so I'll probably do Sunday evening as well. Monday is Notting Hill Carnival, hopefully. So I'll probably skip streaming on Monday entirely, but yeah, you take my point. All good. Until next time. Until Saturday at 9 PM BST, British Summer Time. So that is approximately, to the nearest hour, that is 22 hours from now, I will be back. And what I'm doing next now that I've done the first 2 bits of, you can already see it on my stream page. I've broken it down. So I've done the next index optimization. I've put persist in where I think it should go, and so now I just need to implement the actual state saver and state reloader with the serialization and all this shit. And I think this is just a bunch of needless crap technicalities. I could do this in JavaScript any day of the week, and there are tons of hints in the code, because I can't do it in Go any day of the week because the notation is really weird for how serialization is done. Because JSON is so standard in JavaScript, it's just easy. You just type JSON or stringify, and it saves things into string format, and then you pass JSON.pass to get it back out. Go is just 10 times more complicated, and so this is why I'm not even planning this. I'm just going to YOLO it and grind through it and hope it works. I'm implementing that. So yeah, and then we debug, and that's going to be hella cray. Hella cray. I'm not American, I shouldn't be saying that. It's going to be a mad thing. It's going to be a mad thing. Sick. Done a mad thing. That's it. That's all. I'm just going to continue at 9 p.m. and that's what I'm going to be doing. Part C, Project 2, Raft, MIT Distributed Systems. See you later. See you later. Oh, I've slunk. My ass has just slunk down in my bed so far. Sick. Live. Yep. Thanks again, everyone who visited. I mean, I know no one sees the end of these streams, but I'm grateful for visits, follows, people saying they're finding it interesting. It's cool that it's kind of engaging to some extent, you know. This really obscure computer science project that people can sort of kind of get into it a bit, just watching the stream. Awesome. Ciao.